Now, another nutrient that people are probably unfamiliar with, but you mentioned in the book, is selenium.
Well, selenium is perhaps of the brain-selective nutrients the one I know the least about. It also it works as an antioxidant, which is important. The brain, DHA, is very susceptible to rancidity. Everybody recognizes the smell of a rancid oil. It's a very pungent smell, and we know that we don't want to eat something that's gone rancid, whether it's nuts, whether it's an oil in a bottle, whether it's fish that's been fried and left out, or whatever. So rancidity is a property of breaking up the fatty acid molecules. It's attacked by oxygen that causes these little fragments which are volatile, and you can smell them. Selenium is one of the metals that helps slow down that process inside a living organism. Your brain has got a lot of DHA. It needs a lot of antioxidant protection. Selenium plays a role in that process, not alone, but it's important. It's also these minerals that we mentioned that we call brain-selective minerals often work together. Copper and iron work together to make sure the oxygen supply to the brain is sufficient. Selenium works with iodine, and it helps transform iodine into the right form in the thyroid hormone for thyroid hormone to do its job. So they're linked together, and it's like a puzzle, and you can't complete the puzzle unless you put the pieces together correctly.
Now, you've just edited another book. What's the purpose of that book?
The purpose of the book, Human Brain Evolution, is to really form a bridge between the people who work on the chemistry and the nutrition of the brain and the people who study the origins of the brain. The paleoanthropologists, the fossil hunters, have been able to define the change in the brain size. Humans have a very unique brain. We have unique capacities for creative thought. We have imaginations. We have problem-solving skills. We use symbols. We have language, etc. Everyone knows the technical achievements of humans are unique to humans. It's partly a result of the brain having expanded threefold during our evolution. But it's always been a big question as to how that happened. And some of the explanations don't seem to bear out when you explore in some detail. So we thought that if these nutrients were important to preserve brain function today, somehow the earliest humans and the pre-humans must have overcome those challenges, or the problems that affect the brain development today would have affected it 2 million years ago and would have prevented it. It would have kept the pre-human brain like a chimpanzee brain, a certain amount of skill, ability to learn how to problem solve, but clearly limited compared to humans. So we said, well, if we ate more fish and shellfish, this might be one of the reasons that we were able to evolve and become humans as we know our species today. Well, there are some specialists who work in the fossil hunting business who now recognize that many of the early human fossil sites, in fact, do contain fish bones and shellfish remains, which were not appreciated at the time. And those that documented it had no real explanation for whether the fish was consumed or it was just by chance that it was there. And now we're starting to say, well, if you look at the link with our explanation for the role of nutrition in brain function and development today, you might speculate that that played a role then, and indeed catfish, for instance, were found in many of these African sites. You don't need hooks to catch catfish, you don't need a line, it's not a deep cold water fish like a salmon or a mackerel. These fish were accessible with no technologies, no spear points, no particular challenges. You didn't have to dive down to get them. They were accessible in freshwater pools. So there was no technical limitations to us eating catfish. Catfish isn't as rich a source of brain-selective minerals and DHA as salmon, but it's far and away sufficient for what we need compared to plant sources, which and insects, for instance, which is what the chimpanzees and the other primates depend on. So there was a sort of a quantum leap in our nutrient availability. The very nutrients that protect and maintain the brain today seem to have been more available, starting on the order of 2 million years ago, which is when the brain was just starting to expand, and to have been present in many of these sites as the brain continued to evolve and take its course to today.
So do you think it's speculative, but nonetheless, before farming was developed, say, 10,000 years ago, prior to that, when we were basically hunters, do you think humans at that stage probably lived a healthier life in some senses than now?
Well, they were undoubtedly there were different challenges. They probably had to. There was little in the way of permanent housing, so the issues around the environment and cold environments, for instance, predators would have always been a challenge. And so they would have the degree to which we've occupied all the extreme climatic niches of the world, the hottest intolerable areas and the coldest intolerable areas certainly would not have been accessible. But the degree to which we polluted the planet today was certainly not a problem even 1,000 years ago, let alone a million years ago. So clearly, I would imagine that virtually all water was potable except seawater, unless there'd just been a volcano or some obviously extreme environmental change. So water was available. There was no limit. Humans at that point had not exterminated any animals through hunting, to my knowledge at least. And so we had a very wide range. We hadn't contaminated the planet to any serious extent. So I don't think we put any of the constraints on our health that we have now. But there were undoubtedly perhaps less of a knowledge of plants that were poisonous, and so some people would perhaps have suffered that way, or predation would still have been a major challenge in some areas. In Africa, for instance, lots of very capable predators, and humans are not very skilled at escaping from predators. We're not very skilled at competing with predators. So we had to find a niche which was not quite as occupied by those animals as then.